Each step, one step at a time. Rewrite it, substitute, simplify. That is everything I need to see for the full predicate. So G plus T of 0. This is function notation. It is not distribution. This is not G plus T times 0. Okay? It is not multiplication. Because if it was multiplication, the answer would just be 0. Everything times 0 is just 0. But it's function notation. How would you know that this is function notation? Because at the top of the, above the problem, you're going to have all these functions. I better change my glasses before I fall down from vertigo. So, the rewrite. We're going to take G of 0, and then we're going to add T of 0. We plug 0 into each function. And then we have the answers together. And I want you to do it from left to right. Now, I really wish you want to press me. Every step of the way, you're rewriting this, D plus T of 0. Now, I know room is precious, how messy or how big or whatever you write. But what we're doing is we're completing the answer. So we keep writing from left to right. What does this mean? This means that we're going to go 0 goes in for this X. So if 0 replaces this X in the G of X part, then 0 replaces all of the X's, no matter what. So this is going to become parentheses, and I want to see the substitution. Parentheses, 0 plus 2, so 0, and then a plus 2. And then you square that answer. I want to see that substitution where 0 substituted in for the X. And then it's addition plus T of 0. In the T function, whatever goes in for X, we're going to replace with a 0. 0 replaces all of the X's. So when I plug in 0, we're going to square 0, we're going to add 0, we're going to add 2. And in your head, I know you know the answer is 2. 0 squared plus 0 plus 2. That's a 2. Well, bully for you. It's never just going to be that simple. So if you can practice good habits when they're nice, then you're going to make sure you practice the good habits when they're not nice. You do the same thing every single time, you're going to be guaranteed to do the right thing when it gets tougher. When you learn how to drive, if you signal every time you change lanes, if you look over your shoulder every time, even though you know there's nobody else on the road, it just becomes that good habit you better do when there is somebody on the road. When you do the right thing because you know it's the right thing, you'll get it right every single time. You don't get points for showing off. You get points for getting it right and showing the work. So we're going to add 0 goes in. Now, whether you put this part in parentheses or not, addition is not going to change what you're going to get because addition is not going to change any signs. But Domingo brought up a good point. If I practice good habits, I'm going to add this answer. So I'm going to add what T of 0 is. So 0 goes in, and I'm going to square it. So we're going to square the 0. We want to get squared. And then it's plus 0. And then we add 2. So this is G of 0. 0 goes in for X in the G function. 0 plus 2 squared. and then plus t of 0. 0 goes into the t function. Whatever goes into the t function, you square it, you add it, and then you add 2 to that. So I square the 0, plus the 0, and plus the 2. Show the substitution. Rewrite it, substitute. Now we simplify. So g plus t of 0 equals 0 plus 2 is 2 squared, plus 0 squared is 0, plus 0 plus 2. Now, I don't mind if you take a little shortcut here. That's fine. I'm just writing it out so you see where I'm going. So this is g of t, g plus t of 0. I get 4 plus 0 plus 0 plus 2 is just 2. So g plus t of 0 is just 6. When we plug 0 into the sum of g and t, we get 6. I have to see this step. Rewrite it. I want to see the substitution. And then I want to see the simplify. Now, if you want to go from here to here, I probably wouldn't have a problem with it. Now, it might be more complicated than just, this problem is pretty simple, pretty straightforward, because you're putting in 0. But when it's more complicated, well, I want to see another step. Maybe in the next one. Number 3. J plus H of 2. So rewrite it. That means it's J of 2 plus H of 2. Now I'm putting this one up here for a reason. I'm just effing with it. I want to see who figured this out. So we go and plug 2 into the J function. Now I'm going to replace this X with a 2. And when I plug in 2, what comes out? How are we getting a 2? If I replace this X with a 2, I replace all of the X. There's no X's. If I replace X, J of X or J of 2, I replace all of the X's with a 2, and I don't have any X's. There's no way, no place to put in the 2. Whatever goes in, no matter what, 4 comes out. If 5 goes in, 4 comes out. If 12 goes in, 4 comes out. 0 goes in, 4 comes out. Negative 3 goes in, 4 comes out. 4 goes in, 4 comes out. Square root 75, 4 comes out. Pi goes in, 4 comes out. Happy face goes in, J of happy face. We get a 4 because whatever goes in, 4 comes out. It's a constant. It's a horizontal line. Which means it's the easiest function you could ever plug anything into. But it's also going to be the most confusing thing you could ever plug into. Okay? Because you're sitting there and you're looking at, okay, what am I, where is it? So you just make things up. You start making, your brain starts, you're turning, it's turning, and you start going, like you said too. Okay? Well, the first thing you said was 2. So no matter what goes in, the answer is always equal to 4 because there's no place to replace, there's no X to plug the 2 into. Whatever goes in, we get a 4. So this J of 2 is a 4. That's what it equals. Because no matter what you plug into J, it's going to be a 4. And then plus H of 2. Now in the H function, all right, we're going to replace X with a 2. Whatever goes in, it's negative that thing squared. Negative, we square whatever exits. So it's plus, and I'm going to put it in parentheses. This is where it gets a little tricky. Plus I'm replacing x with a 2, so it's going to be a negative, and then I have my 2, and I'm squaring the 2. Negative x squared. And all I'm replacing is this x with a 2. You notice I'm not putting the square here. I'm not squaring that parenthesis. I'm just putting parentheses around what I'm about to add, because that's what the Navy asked me to do on Monday. And that's fine. My emphasis here is the negative getting squared? Am I going to get positive 4 or negative 4? Negative. Because you see right here, that negative is not being squared, only x is squared. Whatever goes in is going to be the opposite of x squared. So whatever I plug in, there's automatically a negative in front of it. Automatically a negative in front of whatever gets squared, because that negative is not in the parentheses. So when I plug this in, I get 4 plus here, if I write it out, would be a negative 2 times 2. The 2 is squared, not the negative. So that's 4. Negative 2 times 2 is minus 4. So 4 minus 4, j plus h of 2 is 0. That's why I'm giving you that function up there, negative x squared. I want to make sure you realize the negative is not part of what's being squared, it's not part of the base. Number 4 doesn't have any numbers, it's just that. E plus f of x. So rewrite. So that's t of x plus f of x. First step. Rewrite. The next step. Substitute. So t plus f of x is equal to t of x. Well, t of x is, that's it. When x goes in, we get this. That's what it equals. When x goes in, this is what you get. We're not plugging in any numbers. We're just getting x squared plus x plus 2. This is the t of x. And then we're going to add f of x. And when x goes into the f function, we get negative 2x plus 1. So we're going to add, and again, if we're just going to use parentheses to add that next term, we would be adding negative 2x plus 1. This is the f of x function. And here's why, when you do addition, you don't have to put parentheses when you add these two together. X squared plus 2x plus 2 plus a negative is still minus 2x. Plus a positive is still plus 1. When you add, it's not going to change the signs. But when you subtract, you have to put parentheses because the negative is going to change the signs. So it's a good habit to put parentheses whether you're adding or subtracting. That way you remember to put the parentheses when it is subtraction. And now combine like terms. Are there any other x squareds here? Any other x squareds? Yes or no? There's only one x squared term. And then you have a positive 2x and a negative 2x, and they add up to negative positive 2x minus 2x. They cancel out. We get a 0. They cancel out. Okay. And then positive 2, positive 1. 2 plus 1. So t plus f of x is x squared plus 3. If I add the t function to the f function, we get x squared plus 3. Now, here's what I'm hoping. If I actually just gave you this, if I didn't give you the original question, and I just said, all right, here's your problem. Simplify that. Add that stuff together. I'm hoping everybody can do that. We're just starting it one step before that. What would it look like if you had to write it out from scratch based upon the function notation? That's up to you. G plus h of x. G plus h. If I can put it here. So the rewrite is g of x plus h of x. That's what it means. So g plus h of x is equal to. So you got to go get g of x. G of x is this one, x plus 2 squared. X plus 2 squared. And then we want to add h of x of that. And h of x is just negative x squared. Adding it. We have to now simplify. G plus h of x is equal to x squared plus 4x plus 4 plus a negative x squared is just minus x squared. You better get used to going from here to here because you know the special product rule, or you need to be able to distribute. X plus 2 squared is x plus 2 times x plus 2. So we get distribution, x times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is plus 4, there's the x squared, 2x plus 2x is 4x in the middle, and then you have that plus 4. And then we simplified it. One last thing we can do, g plus h. x, x squared, a negative x squared, they cancel out, we get a 0. All we have left is 4x plus 4. Do this from here, this x plus 2 squared, and I go to here. It's time to stop looking at that going, what happened? How did you, because if you're still looking at that and going, where did that 4x come from? It's been happening ever since you took something called algebra from 8th grade on. It's always been there. It's never just been x squared plus 4. That's what everybody wants to make it look like. And if it was, that would be nice. I wouldn't have a job though. Because it's not that simple. That means I have to explain why I got a job. So if you're still doing x plus 2 squared, doing, oh, square the x and square the 2, and it's that, then you have to stop that. You have to stop that insanity because it's never been there, ever. And if you can't get here with the special product by knowing it by heart, then you need to multiply it out. You've got to start convincing yourself. Sometimes when you think something's really easy, you might want to check and think, you know, I don't think I've ever seen something like this before. You've seen, my brain is telling me don't do this. My brain is telling me that stove is hot. I've been told something. You know, something's not right. I'm doing it anyway. It makes sense. So come up and ask. I can't tell you the answer, but maybe I can set you on the right path. All right. Subtraction. Now you have to be careful. Addition, not a big problem. Subtraction, better be careful. Especially when you're subtracting more than one thing. Parentheses matter. Number 6. Rewrite. P minus D of 2. So that's going to be P of 2 minus G of 2. That's the rewrite. So T minus G of 2. Now we substitute. We're going to plug 2 into the T function. So we plug 2 into here, replace it with a 2. Everybody gets replaced with a 2. So we're going to get 2 squared plus 2 plus 2. So T of 2, show the substitution. 2 squared plus 2 plus 2. This is the T of 2. And then it's minus G of 2. Now what's nice is G of 2 actually comes with its own parentheses. It's already there in a parentheses. It's got a parentheses. And then 2 plus 2. And then you're going to square that. I don't need to put an extra parentheses. Minus G of 2. 4 plus 2 plus 2 minus 2 plus 2 is 4. Whoops, not that 4. This is 2. T minus G, 2. 4 plus 2 is 6. 6 plus 2, I got 8. Minus 4 squared, 16. So T minus G of 2. 8 minus 16 is negative 8. You notice I'm not just, I'm following the order of operations, but I'm kind of combining a little bit here and a little bit there. The last thing in the order of operations, what's the last two things you do in the order of operations? What's the last two letters? Addition, subtraction. So the last thing I'm going to do is take this and then minus that. The last thing is the subtraction. So it's okay to simplify this because the last thing I'm going to do is subtract those two answers. So I can clean this up and keep working this here as I work this side and clean that up, because the last thing I'm going to do is do the subtraction between the two. They're still separated. And then I'll subtract. J minus F of 0. So rewrite it. That's J of 0 minus F of 0. So come over here to the J function. What am I going to get if I plug in 0? 4 comes out. So J minus F of 0. When the 0 goes in, this is just equal to 4. No matter what goes into J, you get 4. And then we have minus. 0 goes into the F function. Whatever goes in, we plug it in here. So that's two terms. So we're going to do it in parentheses. It's negative 2 times x, so negative 2 times 0, and then plus 1. J minus F of 0 equals, we got 4. Don't distribute until you simplify that. So 4 minus negative 2 times 0 is what? Yeah. Huh? 0. And what's 0 plus 1? So it's 4 minus 1. What's 4 minus 1? 3. 3. Thank you. Wait, somebody like count on their toes or something. So the answer is 3. 2 weeks, you're going to be wishing we were still doing these things. Because in 2 weeks, we're doing something new. Oh, please let it go back to 2 weeks ago. I miss when we were just plugging in numbers and doing arithmetic. Because we're doing something new. That's math. Every time you just start to get something, oh yeah, let's do something different. That's if you've been practicing. E minus h of negative. All right, plug in our first negative number. Right. E of negative 3 minus h of negative 3. E of negative 3, we plug negative 3 into the g function. So we're going to get parentheses, negative 3 plus 2. And then you square that answer. And then minus. Negative 3 goes into the h function. So minus parentheses. Negative 3 goes in here. Now, there's a whole lot of negatives going on. First of all, it's subtraction. This is subtraction. That's got to be there. And then when negative 3 goes into here, there's a negative out in front. So that negative. And then I got to square the x that I'm plugging in. So then I replace the x with a negative 3. And that's what's getting squared. So this is what you got. This is minus negative x squared. So there's the negative, the green to the blue. And then here I'm plugging the negative 3 in for x, and then I'm going to square. So it looks like there's a whole bunch of negative, and yeah, minus this opposite of x squared, negative x squared. But that's why you just kind of go down the line and you go, you're going here, you're going here, you're going here. Actual just substitution. Don't try to do it. Don't try to substitute and simplify. Don't try to plug it in and then work it out in your head and then write the answer down. I know negative 3 squared is 9. But there's a whole lot of signs going on. And if you're trying to go from, Fresno to Tahoe, you better pay attention to the roadside. If you're not watching for the signs, you don't know what's going on. You know those big old signs on the freeway where they usually don't work, but they try to tell you about traffic and amber alerts and things like that? And usually they don't work though because they tell you silly things. And if you're not paying attention to them, you don't know that 41 South with the connection to 99 South is going to be closed this weekend. But you know what? Half of the lights on that little sign are out on one thing. It's like you can't even read it. If you don't pay attention to the signs, well, I guess paying attention to that sign doesn't matter. So G minus H of negative 3. Negative 3 plus 2 is negative 1 squared. Minus in here. What is this negative 3 squared? This that one. What's negative 3 times itself? Positive 9. Then there's this negative in front. So this is positive 9, but there's a negative in front of it. So it's actually negative 9 in the parentheses still. Got to remember, this means the opposite of x squared. When you square something, it's always going to be what? If I square any number, it's going to come out what? If I square a number, it's always going to be, what's 5 squared? 25. 25. What's negative by parentheses around it squared? 25. So no matter what I square, it's always going to be a positive. But when I put a negative in front of that, negative in front is going to take the opposite of what just happened. A negative in front is going to change them to negative answers. Always. Back to last Wednesday. If you were going to graph y equals negative x squared, what is this shape called? What does it look like when you have a square? A parabola. What is this A in front? What's this number right here? A equals negative 1. If A is negative, what does it do to our parabola? It flips it upside down. Because usually x squareds are always positive. But if I throw a negative in front, it takes all these positive answers and turns them into negative answers. That's why a negative reflects it across the x-axis. It changes the sign of what comes out. So this negative 3 squared, that becomes positive 9, but there's a negative waiting out in front of it. Really bad analogy. I've been a horrible person. I go to prison. I do some really bad things. But I'm reformed. I come out. And who's picking me up? My buddy Paul, who was a horrible person. A negative person. I was a negative person going in. I'd come out positive. I come out. My horrible friend picks me up. I turn back into a negative. Just waiting for me. Because there's a negative outside waiting for me. Okay? But now it's, what is this negative one's worth? That's positive 1. Now I'm going to subtract -9. What happens here?
The negative 9.
Minus -9 becomes +9. All of that is just arithmetic. The only algebra that happened was substitution, right? No, first of all, rewriting it, making sure you understand the function notation, and then substitution. The rest is arithmetic. And what I see when I grade these things is the arithmetic, the order of operations. That you don't write them out, you don't see them clearly. You're assuming things that don't happen. You got to practice that though. Before we get out of here, before we come back at 10, we're going to finish the rest of it at 10. Again, I was watching something on HBO. They're showing. Have you ever heard of the Dream Team? The Olympic team in the 80s. They finally took NBA basketball players and sent them to the Olympics. So we're talking about Magic Johnson, Larry Bird, Michael Jordan, Scottie Pippen, Patrick Ewing. I mean, all the NBA superstars from the 80s. And of course, they will be there. Well, they had a little, as they were practicing, they brought in the All-American college team to play against them, which were technically future NBA players. And the future NBA players on the first day of scrimmage beat them. They beat the NBA players. Because the NBA players had not worked together yet. They hadn't figured out a way to, complement each other. Now, the next day, so the college players beat them by like, I think it was about 4. The next day, the NBA players blew them up by about 50. Because they figured out, we're not going to let this happen again. And then they figured out a way to make it work together. If what you're doing wasn't working, they figured out a way to make it work. Because they knew that's how they're going to win. If what you're doing is not working, you got to figure out a way to make it work. If what you're doing is getting the wrong result every single time, then what do we need to change to make it work? If it means coming into office hours, tutoring, whatever, spending extra time with homework, I give you the bare minimum of the homework because I know you have other things you got to do. But if all you do with that homework is, I don't judge your homework very well. I don't. I really try to give you the benefit of the doubt because it's your key to success on the test. What I look for is people just trying to beat the system. No work, kind of missing. There's supposed to be 50 problems there, but there's only like 30. And you give yourself full credit. So I just kind of look for those things. Are all the sections there. But what you're doing, what I'm here to help. Just try to figure out a way to get you to wherever you want to be. I don't want math to stand in your way. One step at a time. Don't cheat yourself. And when I say don't cheat yourself, I don't mean like cheat. I mean, don't cheat yourself because you can get it right and take it one step at a time. Okay? Take this opportunity to learn it. Feels so much better. Math is instant gratification. You look at the back of the book, I got it right. If you get it wrong, what can I do to fix it? All I did, 2 plus 3 is 5, not 6. It's not 2 times 3. I just wrote it horribly and I can't read my own handwriting. -2 squared was it in parentheses or not? So it's like those little tiny things that are fixed. All right, back to 10.